Today class we are continuing inshallah with the previous eigen values and eigen vectors. I request those who not seen the previous part, first you see the previous part because I explain in detail how to solve the characteristic equations questions are based on eigen values and eigen vectors. Now let me continue one more question here. See here, I wrote the value of a. Now the characteristic equation is mod of a minus lambda equals to 0. Now how to change? You already studied this one. With these three numbers, with these diagonal numbers, we'll get minus lambda. 6 minus lambda, 3 minus lambda, 3 minus lambda. The remaining numbers remain same. This will be a minus lambda equals to 0. 6 minus lambda. What we did here, we just wrote minus lambda with this diagonal elements. 6 minus lambda, 3 minus lambda, the remaining as it is. Now let me expand this one. How to expand? First we take 6 minus lambda into these two numbers minus these two numbers. 3 minus lambda into 3 minus lambda will be 3 minus lambda whole square minus into minus plus 1. So now you write this one. Always this number sign will change because it's minus 2. We write plus 2. We write plus 2. Minus 2 we write plus 2. Now hide this column, multiply this 2 and this 2. Minus 2 into 3 minus lambda minus 2 into 3 minus lambda minus 2 into minus 1 minus 2. Again minus means that will be minus 1 minus plus. Now lastly plus 2 into, when you take 2 here, you hide this one, minus into minus plus 2 minus 2 into 3 minus lambda equals to 0. Equals to 0. Now I am continuing here. 6 minus lambda into, now expand this a minus b whole square is a square minus 2ab plus b square. I am writing first a square is 9 minus 2ab, 2 3s are 6 lambda plus lambda square. Let me first write lambda square, then minus 6 lambda. Now 9 minus 1 we can write 8. Okay. Now the next step also, let me write plus 2 into, first I am writing lambda, minus into minus plus 2 into lambda, 2 lambda. Now let we write the numbers, minus into plus minus 2 3s are 6, minus 6 plus 2, minus 6 plus 2 will be minus 4. Now lastly plus 2 into, multiply this, minus into minus plus 2 into lambda, 2 lambda. Now minus into plus minus 6 plus 2 minus 4 equals to 0. Now let me multiply this all numbers. Now you multiply by 6 first, 6 into all these numbers. 6 into lambda square, 6 lambda square minus 6 6 are 36 lambda plus 6 7 6 8 are 42, 6 8 are 48, 6 lambda square 36 lambda 6 8 are 48. Now this one, minus into plus minus lambda into lambda square lambda cube minus into minus plus lambda into 6 lambda 6 lambda square minus into plus minus 8 into lambda 8 lambda plus 2 2s are 4, 4 lambda minus 8 plus 2 2s are 4 lambda minus 8 equals to 0. Now this will change to cubic equation. Let me first write the cube minus lambda cube. Now the square terms are 2. 6 plus 6 will be 12. 12 lambda square. Now lambda you see minus 36. See 4 lambda plus 4 lambda is 8. Plus 8 lambda minus 8 lambda get cancelled. Now what is left here? Minus 36 lambda. Minus 36 lambda. So lastly 48 minus 8 is 40. Minus 8 is 32 equals to 0. 48 minus 8, 40 minus 8, 32. Take minus common, the first term should always be positive. If you take minus common, this minus will become plus, this plus will become minus, this minus will become plus, and this plus will become minus. This is the cubic equation, lambda cube minus 12 lambda square plus 36 lambda minus 32 equals to 0. Let me take the values from calci. Now see, this is the calculator I am using. First you take mode. If you press the mode, you will have few options. Now fifth one is equation, so press 5. Now equations, the fourth one is cubic equation. Let me take the cubic equation. Now you write the coefficients. The first one is 1, so 1 equals to, now the second coefficient is minus 12, so minus 12, sorry, minus 12 equals to, next one is 36 equals to, next one is minus 32. So get the values. The first value is given as lambda equals to 8 comma, the second value is 2 comma, the third value is not given. Again the same question is coming. I will explain you what to do. Now see here, actually this is cubic equation. We must get three values. We must get three values. Whereas the calci, this fx 991e plus, in this calci, it is always when sometimes instead of three values, the only we get two values. That means the second value is repeating. The second value is repeating. That means that again you have to write 2. This 2 is coming two times actually, but the calculus will give only one time, so we have to take the other value also. So once more I am explaining, this is cubic equation. We must get three values. Suppose sometimes that if the calculus gives only two values, suppose like this, 2 comma 3, that means the second value is repeating. We have to take this two times. We have to take this two times. Okay, so now let me continue. Now we got these three values, lambda equals to, these are called eigenvalues. Therefore eigenvalues or latent roots or characteristic roots means the same. Eigenvalues are lambda equals to 8 comma 2 comma 2. Now for every eigenvalue we must have vector. You see here, for this we will get one vector, but these two values are same. So for these two values we have to get one vector from only two vectors from only one value. From this value of 2 we have to get two vectors. Let me see, we will continue. Let me find the vector with respect to the value lambda equals to 8. Lambda equals to 8. Now you see here, we take vector as x1 x2 x3. Let the three vectors for we have to find for 8 then 2 2. See here, we have to substitute this in this matrix, a minus lambda I into x equals to 0. A minus lambda I into x equals to 0. So a minus lambda is this one into x equals to 0. Already we wrote what is a minus lambda here, into x equals to 0. Now case 1 we have to take for lambda equals to 8. Let me take for lambda equals to 8. For lambda equals to 8, substitute this one. 6 minus 8 will be minus 2 minus 2 2 minus 2. 3 minus 8 will be minus 5 minus 1 2 minus 1. 3 minus 8 will be minus 5 into x1 x2 x3 equals to 0. Now watch carefully. When we keep lambda equals to 8, 6 minus 8 will be minus 2, 3 minus 8 will be minus 5, 3 minus 8 will be minus 5. Now multiply this row into column. These two numbers, these two numbers, these two numbers. Minus 2 into x1, minus 2x1, minus 2x2, plus 2x3 equals to 0. Again here you multiply. Minus, it will be minus 2x1 minus 5x2 minus x3 equals to 0. The lastly 2x1 minus x2 minus 5x3 equals to 0. So we get these three equations. In these three equations you solve any two to get the values. Suppose I am starting with this. Now these two we have to solve. We have seen how to solve in the previous class. We will take from cross multiplication method. You start from here, minus 2 2 minus 2 minus 2 minus 2 then 2 minus 2, minus 2. Again, you have to stop here itself. Minus 5, minus 1, minus 2, minus 5. Minus 5, minus 1, minus 2, minus 5. Here take x1, x2, x3. So this will be the ratios. X1 by minus into minus plus 2 minus minus 10. Again you get minus, minus 1 is plus 10. Equals to x2 divided by plus into minus minus 4 minus minus into minus plus, the minus will remain 4, 1 2 are 2. Then x3 by minus into minus plus minus into minus plus 2 5 are 10 minus, this will become minus 2 2 are 4. I think what is this, the second one equation is, once more I am saying, minus 2 2 minus 2 minus 2, then minus 5 minus 1 minus 2 minus 5. Now see here, let me solve this one. So this will be x1 by 2 6 2 plus 10 12, x2 by minus 6 and x3 by 6. We can cancel this one, 6 1s are 6 1s are 6 2s are. So these are the ratios, we can get many values. Let me take this value as one of the vector, x1 equals to, first vector I am denoting by x1. 2, the ratios you can write, okay, we can have many values, we take one value, 2 minus 1 1, 2 minus 1 1. So this is the first vector, 2 minus 1 1. In the same way, now we have to take for lambda equals to, so the second condition is for lambda equals to 2. Let me solve here for lambda equals to 2. See here, for lambda equals to 2, if we keep lambda equals to 2 here, what will be this, 6 minus 2, 6 minus 2 will be 4 when we are keeping for case 2. See here, case 2, lambda equals to 2. So 6 minus 4 is 2, minus 2 2, minus 2 3 minus 2 will be 1, minus 1, 2 minus 1 3 minus 2 will be 2, into x1 x2 x3 equals to 0. Now you take the 3, multiply, you will get the 3 equations. How we multiply, row into column, okay. So let me take 4 into x1, 4x1 minus 2x2 plus 2x3 equals to 0. If you multiply this one, minus 2x1 plus x2 minus x3 equals to 0. 2 into x1, 2x1 minus x2 plus 2x3 equals to 0. See here, now when we get the same values of lambda, because we got these two values same, lambda equals to 2 comma 2. This is very important topic, listen carefully. Whenever we get two values same, we cannot solve these equations, because these three equations will become same. I will explain. If you take 2 common here, it will be, if you take 2 common here, it will become 2x1 minus x2 plus x3 equals to 0. This also, if you take minus common, 2x1 minus x2 plus x3 equals to 0. If you take 2 common here, this equation becomes this. If you take minus common, this one, and the third one write as it is. Now watch here, these three are same equations. These three are same equations. I done a mistake, I think. So what, just we have done some mistake, let us see. Now see here, actually we are having 1 here. So you put here 1. So this will become like this. You see here, all the three equations are same. All the three equations are same. So we cannot solve this by previous method. I'll explain this also. Suppose you try in the previous method, it will be minus 1, 1, 2, minus 1. Same minus 1, 1, 2, minus 1. So if you solve this one, x1 by minus 1 minus 1 is plus 1, 0. x2 by 2 minus 2, 0. x3 by 2 minus 1 is plus 2 0. So all the three zeros, it is not a vector, okay, this is not possible. So remember this method. Actually this main concept here lies this, when you get the lambda values, two values same, suppose 3 comma 3 or 1 comma 1, when you get the three values same, we have to change the method here. We cannot solve by substitutions methods or by cross multiplication methods. So let me take one equation. What is the equation here? 2x1 minus x2 plus x3 equals to 0. Now we have to solve this by another method. Let you do one thing. We have to take any two parameters here. Let I am taking parameter for this one. See here. Let we write let x1 equals to k1, x2 equals to k2. Now watch once again I am explaining. You take two parameters here. Let x1 equals to k1, x2 equals to k2. Now if you substitute this one, you will get x3. Now substitute this one. 2 into x1 we have taken k1 minus k2 plus x3 equals to 0. Now bring these two numbers on the other side. The x3 will become minus 2k1 and minus k2 on the other side plus k2. Now you got x3 this one. Now we are having x1, x2, x3. x1, x2, x3. Now let me write this one. See here by writing x1, x2, x3 equals to what we are having x1 as k1, x2 is k2, x3 is minus 2k1 plus k2. Now this step is very important. Watch carefully. Next step is very important. How to change it. Watch here. In every element we have to write k1 and k2. k1 and k2. Now watch carefully. Here we are having k1 but not k2. So you write like this. k1 plus, we don't have k2, so you write k0 k2. k1 plus 0 k2. k1 plus 0 k2. Here also we must write k1 and k2. We don't have k1. We don't have k1. So write 0 k1 plus k2. Now lastly we are having both. We write like this minus 2 k1 plus k2. Now this step is very important. You remember this step. We are having k1 k2 minus 2 k1 plus k2. Here we are having only k1 not k2, so we write 0 k2. Here we are not having k1, so write 0 k1 plus k2, because now we can change this into two matrices. The separate, we can separate k1 and k2. Now I am writing it here. Watch carefully. See here. We can write like this equals to k1 0 k1 minus 2 k1 plus 0 k2 k2 k2. Now take k1 common from the first matrix. If you take common k1, you left with 1 0 minus 2. Now you take k2 common here, k2 common here. If you take common k2, you left with 0 1 1. Okay. Now see here, this is a multiplier. We can multiply him. So this is one vector and this is another vector. We can leave this multipliers. So we suppose this as the second vector, this as the third vector. Therefore x2 equals to 1 0 minus 2 and x3 equals to 0 1 1. Already previously we got x1. So these are the three vectors and eigenvectors are 0, 2, sorry 8 comma 2 comma 2. The main thing in this question what we learned is when we get two values same of lambda. Suppose we get lambda equals to, suppose we get 6 comma or 5 comma 3 comma 3. So for these two values, when we get same value, we have to change the procedure. How to do? We have done this with example. So whenever you get two values of lambda equal, we have to change the method. We cannot get by cross multiplication. This equation, in this equation, we have to suppose two parameters, either k1 k2 for this two or this two. Okay, when we take k1 k2 these values, we'll get the third vector. You get the third, sorry, x3. Now you write x1 x2 x3 as x1 value, x2 value, x3 value. In all these three elements we must write k1 and k2. Here we are having k1 not k2, so write plus 0 k2. Here we don't have k1, so you write 0 k1 plus k2. Now you separate k1 and k2. Now take common from here k1 and k2, you will get the other two vectors. So you practice like this one or more questions, you will get perfection on this.